In the last couple of videos, we talked about some interesting facts about tangents and circles, and we proved one of them really specifically. The other one we gave kind of an informal argument, but it would become a proof if we polished it up a little bit. In this video, I want to show you a couple of old Regents questions that put these facts to use. And so this is kind of how you would apply this knowledge when you see it in a problem situation. So let's take a look at my document camera. All right, so the first question here is we've got a diagram below of a circle with a radius, a tangent, and a secant COB. So COB. Secant means it just hits the circle in two places instead of one. So they tell us that if AC is 20 centimeters and OA is 7 centimeters, what is the length of OC to the nearest centimeter? All right, so pause the video, make a sketch of this on a piece of scrap paper and see if you can solve it based on what we know about triangles and circles and tangents up to this point. All right, if you weren't able to get this started, then maybe at some point in the video, if you get a flash of insight, pause the video then and see if you can complete the problem on your own. So, first thing that I love to do, you know this, when I see problems with a diagram and then the numbers are down here, is I transfer the numbers into the diagram. So AC is 20 centimeters. So I'm going to stick 20 right there. And OA is 7. All right. And OC is what we want to know. We want to know this distance right here. So these are the three sides of a triangle. So that's an interesting thing to notice. And what's a fact about tangents that we have learned? Well, what we've learned is that these two line segments are perpendicular to each other. So I've got a right angle right there. So if I want to figure out what X is, how can I do that based on the diagram we've got here with a right triangle? Well, this is one of those key ideas that we hit in geometry over and over and over again. If we know two sides of a right triangle and want to find the third side, we need to use the Pythagorean theorem. So we know that 20 squared plus 7 squared is equal to x squared. All right, and let me grab my little $9 calculator here and off we go. So 20 squared plus 7 squared is equal to 49. And we can take the square root of that. That's what x squared is equal to. So we take the square root of that, and that tells us that the square root is 21.1896201. So what is the length of OC to the nearest centimeter? Rounding that to the nearest centimeter, we get 21 as our answer. All right, so that's an example of a problem where knowing that we've got a perpendicular line and a right angle right there was key to being able to solve it. Let's take a look at a second problem. So this one often tosses students. They don't quite see the situation, but when they've got a circle that's inscribed in a triangle like this. All right, so we've got a triangle and the three lines are all tangent to the circle at F, E, and G respectively. And they tell us that AB is equal to 32. They filled in the diagram for us. AE is equal to 20 and EC is equal to 24. And they want us to find BC. They want us to find this distance right here. All right, so what can we use to help us to solve this problem? As I say, this is something that sometimes throws students a little bit. They don't quite see the tangent lines and how they apply in a diagram like this. So let me cover up part of the diagram. Let me cover up this. So here I've got, well, maybe I'll cover up like this much. So I've got a circle and I've got two tangents to the circle. And one of the tangents from C to E I know has length 24. So what can we conclude based on the videos that we've done in this series? Well, I know that this distance from C to G also has to be 24 because the two tangents from C to this circle have to be congruent. All right, so that's interesting. I've got part of this line segment but I need to know about this side over here in order to complete the problem. So let's see about the other facts that I know. I know that this side is 32, but that's not a part of the figure that we can kind of work with. We don't know about the length of a tangent between 2 points. But let's look at this section over here, this 20. So the distance from A to E is 20. And again, this is a tangent. So what other line segment has length 20 in this diagram? Well, we know that it's 20 from A to F. All right, so just from A to F is 20. So did that move us forward towards our total problem of figuring out this length over here? Well, it does. If we know this distance is 20 and we were told this distance is 32, can't we use that to solve for finding out how long this line segment is? Well, it took 20 to get from here to here, so we've got to subtract these two numbers, and that means that that leaves just 12 to be our distance from F to B. And now we know the length of this third tangent segment, so we know that this segment is also 12. So do we have enough information now to solve the problem? They ask us to find BC, and now we know the length of the two segments that make up BC. And so 12 plus 24 is equal to 36 for our answer. All right, so none of these problems were particularly difficult. You needed to use the Pythagorean theorem for one thing, and the other one was just addition and subtraction. But the key things they're looking for in those problems is being able to identify that relationship between circles and their tangents. And knowing those two facts is going to open up a world of extra word problems and diagram problems that you're going to be able to solve. The ones that I assigned are maybe a little bit, some of them are a little bit different. I've thrown an extra wrinkle or two, but these are all questions from past Regents. So take a look at them, see if you can spot kind of how to put enough information together in order to solve the problems, because there is enough information in both of those problems, all three of those problems, I'm sorry, in order for you to solve them based on applying these two facts that we talked about in this video.